Ekoparty for having me. It's my first time in Argentina, my first time at Ekoparty. It's been amazing. I wish I spoke better Spanish so I could deliver this in Spanish to you, but you would be embarrassed if I tried. So I'm Nate Warfield. I am the Director of Research and Threat Intel at this company called Eclypsium. And today I'm going to teach you how to hack load balancers better than a Russian threat group. The agenda that we're going to go here is I'm going to give you a little bit about my background, somewhat of the motivation that got me to do this research. I'm going to talk about some of the recent exploits that have been used against load balancers, including one that came out this year. I'm going to start talking about a Russian group that has been documented of attacking these things. And then we're going to get into some of the actual deep research that I did. We're going to talk about how I'm not finding exploits in these devices. What I'm doing is I'm abusing by design functionality, kind of like Andy was talking about this morning with Azure, where he's just finding vendor-created systems to use in bad ways. I have some demos mixed inside here. Actually, I've got three demos in here for you. And with that, I think we'll get going. So I am Nate. One of the things that I would say I'm proudest about doing is in 2020, myself, my friend Mark Rogers, another gentleman, Ohad in Israel, as the pandemic started, we saw this need and this risk of hospitals getting hit with ransomware. And the thing that I was looking at was basically network attack surface, and specifically a Citrix vulnerability that had come out in 2019. Through this, we ended up building a volunteer group of InfoSec professionals, about 1,500 of them across there's like 100 different countries. I couldn't tell you how many folks we had in Latin America, I'm sorry, but we did have a lot of people from the US, from Europe, most of the law enforcement agencies across those continents. We were written up in Wired magazine, so it was kind of one of the things that we did for good. There was no money involved. We were just spending our spare time trying to defend, those people that were trying to, on the front lines trying to help through the pandemic. I've been hacking networks in and out since I was about 12 years old. For those old people like me, I was over a dial-up modem at 2400 baud. Has anybody else used a dial-up modem at that speed in this room? Oh, sweet. Way more than I thought. That's awesome. I do security research. A lot of what I do is mostly kind of network stuff. I've been doing a bunch of talks in the last few years, mostly on the defensive side of the house. I did have the illustrious honor of working for F5 Networks, who is one of the vendors we're going to completely destroy today. I worked there for about 10 years. I spent 7 of those years attached to the Microsoft account, so I've helped deploy thousands of these things in every configuration you can imagine. I've also overseen the largest outage in Microsoft DNS history was caused by one of these things. You can ask me about that later. Then when I went to Microsoft, I worked for the MSRC. I was on the Patch Tuesday team. I have the dubious honor of being one of the people that shipped the WannaCry patch. If anybody had installed it, I could brag about it, but I just kind of tell it now. And then I worked for Defender, and I want to point out that I'm not a red teamer. So there's probably better ways to do what I'm going to show you that I'm doing. The point isn't that. The point is that it took me a couple of weeks to figure this out, and it's, like I said, better than the Russians. My Twitter handle is here. That's probably the easiest way to reach me, and that's enough about me. Let's talk about why I did this. So like I mentioned, the Citrix vulnerability is what started CTI League. I ended up through that summer getting pulled in to do incident response. There was a vulnerability in the summer of 2020 that came out that we basically spent the entire, the 4th of July holiday in the United States, our Independence Day. We worked the entire 3-day weekend trying to protect people from this. Come Monday, the exploit code was dropped. Hundreds and hundreds and hundreds of systems across the world started getting hacked. Microsoft's system started getting hacked. So they pulled me in to try to do incident response. Since apparently out of a 225,000 person company, I was still the only person that knew these things well enough to try to do IR on them. And I also wanted a chance to do some sort of offensive research, right? I've mostly done defensive things and try to protect things, but this was an opportunity for me to say, hey, these things are becoming attacked more and more. I have that hacker mindset. I know these things really well. I'll bet people don't know them that well, so let me see if I can develop some stuff that at least I can warn people about. And fortunately for me, back in May, right before the F5 exploit we're going to talk about came out, Mandiant did this really interesting report that we're going to get into. So it was sort of gave me some like trying to think of the word here. It validated what I was doing, right? I was like, okay, this is actually useful information because Mandiant's talking about a threat actor abusing these things. People will actually care. And nobody understands this space, right? Like I said, I was the one guy at Microsoft that knew it. Does anybody here run like F5 or Citrix devices in their network? Not a, oh, 1, 2, 3, 4. Okay, cool. Well, this might be really useful for you. Does anybody like to hack into network hardware in this room? Oh, come on. There's got to be more of you than that. All right. Well, either way, you're going to have fun. All right. So the brief history of load balancing exploits. They're having fun out there. So in 2012, when I worked for F5, there was an exploit that came out that, damn. There was an exploit that came out that I have a microphone, they don't. It was basically they left a root SSH key pair in an ISO image. Somebody figured out how to unpack it, pull the private key off of it, and then they were able to SSH into any of these F5's management sides as root. So that was the first real vulnerability that actually was reported to F5, the first one they ever gave a CVE. In 2019, as I mentioned, the Citrix vulnerability came out. It was actually the technique that was used as a path traversal, which is kind of common knowledge now. It wasn't in 2019, but it should have been because in 2018, Orange Sai, who if you don't know who he is, I suggest you go look up Proxy Shell and all the Exchange vulnerabilities. He's the guy that found those. He did a Black Hat talk talking about path traversals and how you could do all these evil things. So 18 months or so later, this comes out, nobody paid attention. The POC for the Citrix vulnerability was quite literally in his slides. Not to be outdone by their biggest competitor, a few months later, F5 decided to have their own path traversal vulnerability. This would give you access to a Java servlet page implementation of their API, which is actually completely undocumented on their website. Nobody knows really why it's there. And then, like I said, this beautiful one came out in May this year. I was going to originally do this talk with the 2020 vulnerability, and I kind of died a little inside because it's extremely complicated and it doesn't work very well. This new one quite literally gives you JSON output. It looks just like the shell, so it made a lot of this a lot more fun. These things, wide-scale exploitation happens quickly. With Citrix, with the first F5 one, nobody really knew it was there. We don't know if anybody exploited it. F5 certainly isn't going to tell you. With Citrix, I did a talk about this a couple of years ago. It was about 4 days from when the POC was dropped on the internet to when wide-scale exploitation started. The 2020 F5 vulnerability, it was about a day or so from when POC came out. This most recent F5 vulnerability is a matter of hours. So like the window to get these things fixed keeps getting smaller and smaller and smaller. And I also have this thing about exploits that fit in tweets. Like it's a $90,000 piece of equipment and you can hack it with a tweet. So that's fun. So we're going to go into the one from this year, this 2021. So you'll get a little bit more of the architecture here in a minute, but the long and short of it is what you do is you send a request to the management IP address. And I'm highlighting in red the stuff that's bad. So this management path is essentially an implementation of the bash shell that can be reached from their own proprietary TM shell. What you do next is you forge the referrer and the host to be localhost. The reason for this is that when this is working as designed, you're supposed to be authenticated against the system, so there's an authenticated token in the UI that the Java Tomcat engine then forwards this request inside to the database that runs all of their configuration and says, hey, can I run this command? So when we say referrer is localhost and host is localhost, it's just spoofing that where this request is coming, the call is coming from inside the house. But here's the worst part. What they did was they allowed it so that you can maybe see there's a comma after this connection close. What it allowed you to do was it allowed you to stick an I5 authentication token into the end of the connection close header, and the F5 would be like, okay, cool, you're authenticated. That authorization basic string is literally admin Horizon 3. Horizon 3 was the company that actually wrote the first POC for this. And then you'll notice that on the bottom of that header, the F5 auth header is basically blank. So all it needed to do was say, hey, if it comes from localhost, if it has this F5 auth token inside the request, cool, it's authenticated. The lesson here is don't authenticate things based on a header value. Like this is literally 20-year-old bugs, right? And then once you do that, you just pass in the data command that says, okay, I want to run whatever bash command I want. In this instance, you're basically saying run the ID command on the command line of the device to tell you that, hey, you're root. So that was the sort of exploitation thing. And then this Mandiant report comes out in May. And I'm going to let you kind of read some of these details. But some of the things that I thought was interesting when I read this was, they talk about going after these network appliances, putting backdoors on SAN arrays, load balancers, things with BSD and CentOS operating systems. They even say it would require considerable planning to compile functional malware for them, which is like, yes and no. Then they start talking about their backdoor, which is basically a modified drop-bear SSH client with hard-coded credentials inside it that didn't actually run that well, and it wasn't persistent. So if the thing got rebooted, and for sure if it ever got upgraded or patched, their access is going to go away. They even tried to make this thing persistent, right? They said they are going to put it into cron, but it didn't actually do it right, or it tries to change itself name to cron, it didn't work. It was so bad that they actually had to put a web shell on some of these systems so they could use the web shell to restart their implant, which is just APT, I don't think so. And they're doing the right thing. They're going after devices that are hard to monitor, right? They don't have AV, they don't have EDR. They're these big expensive network switches that nobody wants to touch because it's like, you don't touch a core router unless you have to, you don't touch a load balancer unless you have to. Mandiant believes that these are attributed to a Russian threat group, more of a cyber espionage than like a Sandworm or any of those folks. But they do have techniques that overlap APT 28 and 29, right? Attribution is hard in this industry. So I didn't really think this is very impressive. I said, you need a web shell to restart your implant? Like that's like script kiddie stuff, right? It was also weird that they were going to go and use all this custom designed drop bear and they're going to compile it with credentials. It's like, why go to all this work? Like if you're not going to write something cool like InDestroyer or Stuxnet, like don't waste your time if your like custom code is crap. There was no persistence, right? I was like, okay, this is cute, but if you reboot the box or maybe if you just let it sit long enough, it turns off, right? This isn't very advanced. And I was like, I can do better, right? And I kind of wanted to say, hey, can I do better than a Russian threat actor? Like, I don't have a leopard print Lamborghini, but I can probably hack a computer better than them. So the reconnaissance phase. This really boils down to, I read the docs. I RTFM'd and I figured this out. Like, if I can do this, you can do this. And the scary thing is the Russians can too. There's going to come a day when somebody's going to refer to this talk and they're going to be like, this guy told those guys how to do this thing, and we should be mad at that guy. Not the vendor, but that guy. You hit it here first. So, load balancers, what are they? These are basically just, think of them as big pieces of networking equipment. I could have put a photo in there. It doesn't really matter. If you've ever seen a gigantic network switch or a thing with 100 Ethernet jacks on it, that's all they look like. They come in everything from a 1U to a 4U. Like they cost, starting at around $90,000 up to about $750,000 a piece. And they generally buy them in pairs of devices. So if one fails, then they can flip it over to the other one. If you've done any sort of network engineering, that was one of my things I did most of my career. HSRP, or Hot Standby Router Protocol, is a very similar technology where the gateway address that all of your resources are talking to never goes away, it just sort of switches from one Ethernet port to the next, and the servers have no idea. These things do layer 4, layer 7 load balancing. They're used as web application firewalls sometimes. Because these companies like to sort of shoehorn every piece of functionality into them, they also do VPN endpoint stuff. They load balance DNS. They will also do SSL and TLS offloading. One of the big selling points was these things had really powerful SSL chips. So you could, buy one certificate, process lots of SSL. They generally are deployed in places where they have full network access. A common way they do this is you plug it in, you put a big Ethernet trunk, tag a bunch of VLANs, and then you can just talk to whatever networks you need to load balance, or if you've got database servers, you need to talk to these servers. It all goes through the load balancer. They technically, people will say, we say they run a firmware. Technically, it's a full-blown operating system. And as I mentioned before, they're proprietary. There's no EDR that runs here. Nobody makes one. There's no antivirus. NDR stuff, you can put it upstream or downstream. But none of these solutions have a system that supports any of this stuff. So you basically have remote syslog and remote syslog. Internally, and this is the idea here, is if you're going to go hacking these things, part of this is to teach you what they are and how I hack them. But if you're going to go and hack these things as, say, a red team engagement, this is how to do it and not get caught. So you understand, these devices have what they call a data plane, and then they have what's called a control plane. The data plane is where all of the load balancing, proprietary, vendor, magic, next gen, super gen, whatever they call it, stuff that they sell it for happens. And the control plane is literally a Linux or a BSD operating system. It's stripped down, like they take all the compilers out, they take out Python 3, so all the fun tools like Impacket and Responder don't work. But they do have some stuff like LDAP tools, SMB, you've got cron, TCP dump, netcat, some of the standard command line stuff, but it's more than like a busy box installation you'll find on an IoT router, right? And the nice thing about these things is, for us, most people manage these via a GUI, right? It's got this big, sexy web interface. Nobody wants to deal with a command line. That's where most of your admins live. But the full shell access is what we get to abuse as hackers. And then, because of these things having SSL termination, they keep SSL certs and keys on the file system, not in an encrypted vault, not in a hardware security module by default, just as a text file. And this is, for example, what an F5's config directory looks like. This is just from my VM. Like, this isn't a machine that's been running for that long. So there's, inside this directory structure, what, 1,032 files. Like, tell me you're gonna find my 2 bad files out of 1,032. So, the capabilities of these things, if you're hacking into one of these, what you don't want to do is you don't want to touch the data plane. It's all uses very proprietary configuration stuff. It's handling production traffic. You know, if you screw something up here and knock a website offline or knock a server pool offline, like, it's going to set off alarms, people are going to come looking, you're going to get caught. Now, there is some stuff you'll see in the long form demo where I know what I'm doing, and I'm going to hack the data plane to do some evil things, and you'll see that later. But the control plane is pretty much safe, right? It's just a Linux BSD system. You can screw around in here as long as you don't do something silly like run a gigantic logic bomb and crash the control plane, you'll be good to go. Most of these things, the ACLs on their device interfaces can be changed. Nobody's going to notice it. The only thing you really have to worry about is if they're doing remote logging and if they're using remote authentication, because if you maybe try to brute force it, they'll see it. Or if you're doing something bad, they might pick it up in their log server or their Splunk or whatever they've got going. And they also have capabilities for most, they basically just keep slapping functionality on these. So F5, when I started working there in 2001, basically did HTTP and SSL load balancing. Now, their last time I heard of them, they actually can run, they're running inside 5G cell networks. They're doing all these crazy protocol things that the 5G networks use. They will continue to add functionality to support network providers, regardless of what it is, which is also where they get in trouble. And the other fun thing that we're going to talk about a little later in the demo, F5s let you manipulate HTTP headers with cookies to do persistence, but you can also do TCL/TK inspection of traffic and manipulation in real time. That is a very complex thing to do, but it's all sorts of evil things you can do if you know it. Now, to their questionable design decisions. They decided to enable the GUI and SSH on every single device IP when you turn this box on. Now, those of us that use networks or network devices are used to having, a switch, and then there's an actual port, a physical port that you plug in to your management backplane, right? And that's the only place the management people can connect to. F5, on the other hand, says, well, we'll do that, but then all of the other device IPs, those sort of HSRP addresses, we're going to put the management enable it by default on all of those too. And they don't really tell you this. And you can get, all of these things get the GUI, all of these things get the fully interactive bash shell if you can get into the box. The other fun thing is that because they're Linux-based and they haven't figured it out yet, the data plane and the control plane share a routing table, which may not seem like that interesting until you realize, well, if I can get into the management network from, say, somebody's desktop and some administrator desktop, and I can see the management interface, but it doesn't have an internet gateway, you can still hack in through the management, and you can talk out through the internet from that side, right? There's no separation of those two planes. And then my favorite part, and this is going to be really fun, is they have multiple, by design, documented ways to run scripts on these things. It's all in the command line. You'll never see any of this stuff in the GUI. You can run it when they boot. You can run it when they fail over. You can run it when a syslog message fires. And you can just configure all of these things in a script. There's literally no way to see this stuff if you're a GUI administrator. You have to go on the command line, and you have to know what you're looking for. And the other fun thing, too, is, like I showed you the screenshot of that configuration directory, it's huge. There's tons of places we can hide. There's no integrity checking on any of the files. They don't have a list of, specifically only these files can be backed up. They just basically zip the whole thing up, which is where we're going to go next. So what they do when you upgrade these things, let's click that in. So their backup file is essentially just a tarball. And when these devices are upgraded, you've got two of them. The process is essentially, you take the one that's not processing traffic, what they call the standby device. You say, I'm going to install the latest and greatest version, or I'm just going to install a security patch for the vulnerability that Nate exploited. What it does is it lays down the operating system into a new boot location. If you think of like multi-booting Windows and Linux, exact same thing. So it lays it down, puts all of the operating system files in there, and then what it does is it says, okay, I'm going to zip up all of my configuration on this installation, I'm going to copy it over to that installation, I'm going to unpack it. No integrity checking. The same file is what's used for device backups, right? This is the thing that it's sort of the master file where you restore your F5s, back up your F5s, take configuration snapshots, you use this thing too. And then they have another fun thing, which is there is one partition that is shared between all bootable operating system versions, right? Because they're not patching it on that running system, so every time you install, it basically lays down a brand new fresh copy. So they do need a place to keep stuff that they might want to persist across different installs, like your statistic stuff, like how much traffic has this thing processed in 30 days. So there's actually a partition where you can drop things, and it'll stay regardless of which boot version you're in. So persistence the easy way. The first thing I started doing was looking at how can I just get this stuff to run on either failover state change or logging messages. So this paths, and I will post these slides to GitHub probably tomorrow, so if you want to follow me on Twitter, I always tweet the link out. I realize now looking at them, this might be a little hard to read in the back. But this config failover, and then there's 5 files in there. There's an active, a standby, and then 3 different files that start with TG, which is a traffic group thing. This string underneath it is all you need to put into one of those files. Basically, you'll notice that there's that -c like we saw in the exploit. TMSH is their shell. We say, run util bash with a command of, I also hide my my runner script inside this failover directory. We'll get to that in a minute. So it just says, okay, run the script when the device goes standby, when the device goes active, when the traffic group, any of these changes of state, it'll run the script. The next one is the syslog message, where I say, okay, if you see a monitor status down, like when a web server goes up or down, run this script. So, the script. What I did, obviously I used their exploit, and then this script that I wrote, I took from their website. I didn't actually have to do much with this. I was like, well, how do I write a script that runs after the device starts up? They're like, here's a solution that shows you how to do it. I was like, thank you, F5. And then I used Sliver C2. And if you have, anybody here heard of Sliver C2? I know you have, Andy. Okay, a few of you. So Sliver is actually really cool. You've probably, okay, how many here people have heard of Cobalt Strike? Okay, yes. So Sliver is like a Cobalt Strike, but it's free, it's written in Go, it's awesome. I actually got to meet the developer of it from Bishop Fox a couple months ago. It's a really solid, robust C2 framework. Now, I have never used Cobalt Strike or Brute Ratel or any of those, so I couldn't tell you how it compares, but I think it's great because, like I said, it's free. And then I wrote a script. This script, essentially, the parts you care about are sort of below the comments about a secured REST Java D does not exist. And what it does is when it's run, it sleeps for a few seconds, a random number of seconds. And this is to prevent, I don't want this thing to start more than one copy of the C2, right? If it goes crazy, if I run it from cron, maybe I'm going to get 50 copies of this process running. And if someone says, well, there's a weird activity happening, and they find 50 copies of the same process, they're going to be like, well, that's not good. So it basically just checks. It says, hey, is anybody running? No? Cool, I'll run. If it's not on the device, it says, okay, well, if it's not here, I'm going to go grab it. Now, F5 tries to mount their /user file system as read-only. It's a security thing. So we just remount it to read-write. We grab it, and then we time stomp it by essentially saying, okay, I'm going to go pull the timestamp off of a binary in user bin, like sysctl or systemctl, time stomp the implant binary with that timestamp, mount it to read-only again, start it. The idea is if somebody goes in and says, what's this process running user bin rest java D? What is that? Oh, well, it's the same timestamp as everything on my device. It must be fine. And also, we could, if we wanted to, oh, hold on a second. Let me go back before this goes. There we go. If we wanted to, we could put the implant into the backup, like we could store it in the config file system. The problem is Go implants are like 16 megs, so it's a little big, and it might get noticed if all of a sudden, like, one day their backup goes from 5 megs to 21 megs. They'll be like, well, that's weird. So here is the first demo. This is persistence via syslog. You'll see the sliver screen. You're going to see me start tailing the log files on the F5, or actually, first I'm going to show you that config that I wrote. And then we're going to watch the log files. And then the screen below this is my Apache web server that's just set up. You'll notice Sliver has nothing going. We're going to turn off Apache. You're going to see some log messages spew up here on this F5 screen. Now, it's sleeping for the random seconds. And then there comes the C2, right? So it just popped back. Now I have a shell on this F5, right? All it did was do what it's supposed to do, and we're in. So, The other fun thing about these devices is that their architecture allows you an ability to pivot. What they don't, the way these are designed is when you deploy them, you've got the devices and a bunch of VLANs. It's acting as the default gateway for all of your web servers. Traffic will say come in from the internet, it's passed through the device, it passes it along to the web server says, okay, it's an internet machine, I'm gonna pass it to my default gateway, everything works. Now, if you have to manually configure the device to say, I wanna let this web server initiate a connection on its own out to the internet, right? And so unless you go and say specifically, let these servers talk to the internet, it won't let them do it, right? This is a secure by default thing that they talk about, except it's not. Sliver allows you to do pivoting. So essentially, I can drop a sliver implant on an F5, and then I can drop an implant on a Windows server, say. And that Windows server can't get to the internet. But if my sliver implant can talk to my C2, and my server can talk to my sliver implant, I can now get that server out to the internet, and the F5 is none the wiser. I couldn't believe that I was able to bind a daemon to a port on a networking piece of hardware. I was for sure this wasn't gonna work. It turned out all I needed to do was open up the ACL on the port, and it was perfectly fine. Like, it kind of blew my mind. Yes, like I said, it lets you bind these listeners to the failover addresses. You can bind as many as you want. The changing of the device ACLs will never show up in a configuration, right? So when I mentioned don't touch the device configs, I left out a part, which is that the F5s, and I think the Citrixes as well, what they do is they have a process that kind of checks, hey, do we have the same config to make sure if something happens, they're not gonna like all of a sudden fail over to the old and last month's configuration. So they're smart enough that if you go and change part of the load balancing or the data plane configuration on one device, the other device will pop up with a warning saying, hey, configurations are out of sync, right? And if your admins are paying attention, and if they're logged into the console, or if they have some sort of a SNMP trap set up, they might notice this. That's not true when you're touching the device-specific configuration. I can add routes, I can add DNS servers, I can open ACLs on the device, I can open up, if the device isn't allowed to talk to the internet because it has an ACL saying this device can't go to the internet, if I'm root, I can get rid of that ACL. This will never show up, and it will all get saved, it'll be in the backup files. It's kind of amazing that there's so little oversight into the most important part of these things. And like I said, any of these default gateways will route as C2. Now, in fairness to F5 and to Citrix, I went and started looking is this a common, is this common, right? Is this just these two vendors implemented it stupidly? It turns out not. Juniper routers do the same thing. By default, the control plane and the data plane will share routes. If somebody needs a default gateway and one side has it, it gets used. So, A10 does the same thing. A10 is an interesting case. They were actually one of F5's bigger competitors. And I grabbed a virtual machine of their stuff. They don't let you have a full shell. They only give you a restricted shell. And as it turns out, these techniques are very, very difficult, darn near impossible if you don't have an interactive shell. When they restrict you to only the specific set of commands that you're allowed to run, you can't get into the file system like I did. You can't figure out, okay, what can I run? How can I hide things? Citrix has initially what looks to be a restricted shell when you log in, except that they have a command called literally shell that gives you a bash shell. So that's how we're able to do what we'll talk about with Citrix a little later. So I'm going to let you, this is going to run in a loop. So this is basically an example of what happens if you infect a backup file on this F5. Now, like I mentioned, these full archives are dangerous. And what's going to happen here, just so I'm going to talk over this, right now it's loading a configuration on an F5 that has this malware inside it. And it takes a little while because it takes a long time to initialize and other things. But the thing about these that's interesting and why these archives are dangerous is that both of these devices do support what we call a flat configuration file. That use like a Cisco router, if you've ever used one of those, it'll actually just, you can copy the thing off, put it in Notepad, paste it back on. You see the C2 just popped up after the config install. We're going to let that run while I keep talking through this. So they have these flat configs, and those are safer, right? Because you go to a Cisco router, you show running config, you copy it off. There's no way there's going to be any malware in there, and even if there was something malicious, you'd be able to see it, right? F5 and Citrix have been basically required by their customers to do the same thing. But it kind of works, but it doesn't really work. So most customers, at least when I worked at F5, the 30,000 customers we had at the time, nobody used the flat configuration. Everybody used the archive version. So these abuse scripts are, of course, included in the config backup, which is why we're able to do this. And then the reason that this is happening, you'll notice that the startup, there's failover, and there's syslog, right? Now, none of these actions say installation, but what happens is that when you install this configuration on a device, it says, okay, I'm gonna take all this stuff, I'm gonna load it up, and then as it starts to come online, it goes and looks and it says, do I have a failover partner? Because I need to figure out whether I should go active or standby, and you see where I'm going with this. And then once it figures out what to do, it says, okay, cool, run the failover script for active or run the failover script for standby, and that's what kicks this off. And so I use this failover star because in the long form demo we're going to go through, I basically just spray that payload at all of the scripts inside that directory just to make sure, it's the only way to be, infect them all from orbit. It's the only way to be sure. All right, so this is the actual long form demo. This is the longest demo I've ever seen at like 4 minutes. And I'm going to talk you through this. I'm going to try not to go too fast, but it is complex, so bear with me here. Actually, hold on a second. Let me give you, before we do this, the architecture of this lab network is essentially this. There's 2 F5 devices. They're a failover pair. Behind them is a Windows server. These things are talking through a router that goes out to the internet, and my attack is coming from essentially a system that would be inside the network that can talk on the management side. The management interfaces cannot talk to the internet. So this is that design scenario I was telling you about where you secure management, it can talk to the internet so it can pass web traffic. And that's what I just need you to know before we go into this. All right. So what I'm doing here is kind of showing you this stuff, right? These are the 2 F5 GUIs. This is our goodguy.com website that our customers go to. They're like, oh, these guys are so good. And then what we're going to start doing on the F5 here is I'm showing you, this is watching the logs, right? There's a few things I didn't get into for time constraints, but what I'm going to show you is keeping stealthy. The exploit will let you turn off syslog. So you'll notice when I do this, it shows me that a command was executed, right? This is, okay, an admin's on the box doing something, right? If I'm trying to hack in, I want to be stealthy, so I'm going to go and turn off syslog. And see how nice it is? It even tells me, it echoes back the command line prompt saying, shutting down syslog. And now you'll notice as I'm basically looking to find the other device that nothing's going to show up in the F5 logs. So what I have to do is I have to figure out where the other device is, because I'm going to do some stuff that's going to change the configuration of the load balancer, so I need to know how do I synchronize this to the other one so that nobody notices I'm doing what I'm doing. And I'm using the exploit here with just basically F5 commands to give me all this information that I need to know, and I've only hacked into one of them, right? I'm only hacking into one of them right now. I found the second one, I turned off syslog on that one, and now what I'm going to do is throw the exploit payload that takes my implant, puts it on the first one, and it starts it on that side. So the implant's running. On the second one, I'm just going to install it. I'm not starting it yet. So you'll see that this has an actual shell to the first device that I'm on. I'm going to use this shell in Sliver, and then what I'm going to do is I'm going to set up my pivot listener, right? So it starts it up. I need to go and open that port. So I execute this ACL that opens up the pivot port, and now I'm going to go hack into a Windows server. So it's the same machine that hacked the F5 is now going to go use Metasploit. So first I need to hack into the F5 again because I need a place to pivot my Eternal Blue exploit back into the back-end network with this Windows server. So we get onto the F5. We're going to pretend I didn't know and didn't build this network myself. So we're going to go ahead and we're going to port scan that back-end network and see if we can find some Windows servers. And like, oh my God, there's a Windows server back there. Who would have thunk, right? So we find our Windows server. We're going to assume that they didn't listen to Nate and they didn't install the WannaCry patch. So we're just going to go ahead and throw Eternal Blue at it and see what happens, right? And lo and behold, they didn't. So Eternal Blue runs. Gorgeous exploit, by the way. And now we've got a shell on the Windows machine. For time constraints, I didn't upload the implant. It was already there. And now you can see I've got a pivoting account. I've got this Windows server has now pivoted through my F5 to the internet on my system. Now, this is what I love about Sliver. It says, this is bad OPSEC. Are you sure you want to do this? So I'm dropping to a full interactive shell on the F5 because now we're going to go and actually mess with the load balancing config. And this is that iRule stuff I was telling you about. So what I'm doing is I'm creating basically a traffic redirection rule. This is extremely basic type of thing where it's going to say, when I get a request to the website, I'm going to send it somewhere else, right? And notice that the top, the F5s are going to say, see that says changes pending at the top? That's because the config is changed on one device. This is where you get caught. I'm also modifying the virtual server to say use this traffic rule when people hit this website. And now I'm going to say run the configuration and sync it up. And all of a sudden they go back to, oh, everything's in sync. Situation normal. Everything's normal. How are you? So what we do is we drop out of that, and we're going to go say, let's go to this website. And lo and behold, it's bad now. Like our traffic is going somewhere else. Now I could be putting a JavaScript like keylogger in here if I knew JavaScript. But you know, somebody calls the SOC and they're like, oh my God, something went wrong. So, you know, good old SOC guy goes, oh man, we better fail that F5 over because it's now handling out like bad traffic to people. So he puts that thing into standby mode and the second one connects. And now I have both your F5s talking to me, I've owned your customers, I've got your Windows server, and that took all of 4 minutes. Now granted, the preparation time for this video did take a little longer than 4 minutes, but that's how easy this can be, right? So, in fairness, so I did all this work and I was like, okay, F5 is pretty busted. I can do all these evil things to F5. Citrix was my next target. And Citrix doesn't have quite as many design flaws, but they do give you a fully interactive shell. They do have the ability to back up files in an archive. They also don't have interactive or integrity checks. And once again, because they're zipping up a directory, I could, if I wanted to, store my implant in that config directory. This would be useful in situations where maybe you know the admins, you can see the admins aren't really paying any attention. They're like, I don't want to risk this thing not getting into the internet, or maybe you just want to have it talk to your, you know, somebody in accounting's desktop that you've already got a sliver implant. You could chain these things through. You could have a pivot implant on an F5 talking to a sliver implant here. Like you could just keep going as far back as you want. But I needed to install some way to imbue a built-in service, right? Because once again, if I was to drop something into like an init script in Etsy, that's going to get wiped when it gets reinstalled. I can't really, it's BSD, so there's a few less ways to run code, and I also don't know BSD as well as I know Linux. But I want to make sure that this is invisible to GUI users, so I don't want to have it as like an official job or official scheduled task in Citrix. So I went digging around. It turns out there's not that much to play with, right? They have this, how to install a custom file solution. Once again, vendor website, wealth of knowledge for this stuff. And they're like, okay, you can tweak the daemon configurations like SSH and the web and the syslog, but the thing is none of these are executable. Right? These are just configuration files. And I think cron tab is kind of I don't know, I think it's kind of like being too easy. I mean, the first place anybody's going to look on a Linux machine for bad stuff is cron, right? So as I dug around, I came across this weird thing buried in the manual that they're like, yeah, if you need to get your NTPD service to do these things, go and make this file and do this thing. And then to the bottom, I was like, this process runs every time the load and the ADC is restarted? Okay, interesting. So as it turns out, their solution that they gave me of put things in this rc.net scalar file didn't really work. I tried sticking everything I could think of in there. I tried copying the format, everything, nothing ever worked. So I was like, okay, where does this NTPD control thing? So I started digging around in their Etsy directory, and I found there's a whole bunch of these _CTL files. Some more digging around, and it turns out that they use this package that I'd never heard of called Monet, which is a BSD package for managing services and keeping them running. And its configuration file is one of the ones you can configure, and it'll get backed up. So at this point, I was like, sweet. It's not quite as easy as just starting the script, though. So I ended up having to write like a full service wrapper for Sliver to make it sort of run like a daemon. Like I had to create a PID file, and I do all these other things so I could actually accent like basically implant start, implant stop, implant restart. But I used the same logic in this script. And what it does is now it allows Monet to manage my C2 for me. It starts on boot, and the funniest part about this is it makes the implant completely unkillable. So when you're in Sliver and you're connected to an implant, if you decide that you're done with it, you can say kill, and it kills the implant and it stops the process on the remote system, right? The implant's gone. If I do that on a Citrix device, it says, okay, session died, it goes away, and then a couple seconds later, it connects right back. Because Monet's like, oh, this went down, I better turn it back on again. So it's kind of funny because you can't make it go away once you've done this. And so these are the scripts, right? So this big block right here is basically what I had to do. You know, you can see start. I called this NS support. That's another detail I forgot to mention. What I did to hide my implant on the F5 and on the NetScaler is I go and find daemons that look innocuous. In F5, they use the run service, and so they had a run service for REST Java D, but there was no actual binary named that. It called a long Tomcat initialization string. So I'm like, if I name my binary REST Java D, and so even an admin who knows what he's doing looks, he's gonna be like, well, that's the service and that's the thing that started it, we're good to go. For NetScaler, I just said they have a bunch of stuff that's just NSS something, so I'm just gonna call this NS support, like NetScaler support daemon. And then you can see here on the screen, this is what the boot, it's a console boot up process. It basically says, hey, your implant's not running, I'm gonna start it for you. And all these scripts, I'm actually putting a blog out, Eclypsium, my company, I'm writing a blog to detail all of this. All of the code will be made public. It's not that hard, but I figured, hey, why not? So, kind of getting, getting towards closing here. It's dangerous to act alone, right? If you're interested in doing this, I really encourage you to, because as like even Andy said this morning, like Azure is a sort of a wild west. People aren't really looking at it, so there's all sorts of things to find. Load balancers, people aren't really looking at them that much either, right? The vulnerabilities that came out in the last couple of years are trivial. So my entire lab is running on Proxmox, which is a free like KVM management thing. It uses the KVM hypervisor. I have a little desktop, little box thing that's, cost, I don't know, 800 bucks. It wasn't much. And I run VMs on everything. The fun thing about F5 is that you can just use a throwaway email, like go to throwaway mail, get an email address, register for their support site, and you can download everything you want. The great thing about them too is the reason that exploit worked is you can download vulnerable VMs. Like when they patch a vulnerability, they don't remove the old vulnerable code off the website. You can still go and download things that have vulnerabilities in them, which kind of blows my mind, but hey, I'll take it. And then you can actually get trial licenses. So you could use that same throwaway mail, go in and say, hey, I want a 30-day eval license. And they'll send you 3 eval licenses so you can have a fully running pair of devices like I had in there. Then you can also download ISOs. I think it was Silvio before was talking about downloading firmware stuff. If that's your jam, you can download an ISO, you can unpack it, you can look at everything in there, right? You can figure out all the binaries, all the versions of everything they're doing. I don't have the time or the motivation to do that and actually try to find vulns. I leave that to people that are smarter than me. I just like to abuse things after they find them. Citrix has the same stuff. You can get VMs from them. They don't really give you the vulnerable versions, but the cool thing is they don't need a trial license. So you set up an account, they'll give you the VM, you turn it on, and they get a 30 or a rate limited but unlimited time license for it. All right, and with that, some key takeaways for this. These techniques will work on any device that has a full shell. I, at my spare time, will probably go and try to get more VMs. Maybe I'll do Juniper. FortiGate doesn't give me a full shell. I was playing with that exploit a couple weeks ago. But theoretically, anybody that gives you a full shell, this is probably possible. Advanced actors, I don't think, have really gotten to the point, obviously where I'm at. That may change, as I said. But this is an area that's going to continue to be abused. And, some people may say, well, but everybody, if they patch, you're fine. And the truth of the matter is that these devices don't get patched that often, right? They're complex. They run in the middle of networks. People may think, well, this thing is secure because it's not exposed to the internet. But if you can get in through some other path, you can get to these devices. When I worked at F5, people couldn't stand upgrading these things because more often than not, they'd put the new code on, it was super buggy, they'd take an outage. So they were like, I'm only upgrading if I absolutely have to. So these things will run for years without being patched. They're complex. Like I said, most of these people are using the GUI. We get on the command line. Nobody knows what we're doing. And then they're design flaws, right? These vendors have basically shoehorned all of this functionality into these things at the request of some customer some time ago, and it never goes away. And they're never going to take it away, right? In the same sense with Microsoft and some of the boneheaded stuff like NTLM that's going to be around for the end of time, they can't get rid of it once it's there. So what can you do? Patch them, firewall them, turn on syslog. Start maybe looking at your config snapshots, look for size changes. I don't have a lot of great advice for you here because it's not easy to catch this stuff. You might be able to run something where you hash all the files in the file system and say, hey, if anything changes, if all of a sudden one of these startup files gets bigger, I want to know. Or if you're going to go and deploy these things, try to find boxes that have more restrictive shells, right? Yes, they can still get hacked. Pulse, I have one of those too. Doesn't really have a good shell. I can hack into it, but I was never able to get these implants to run, right? Something about how those things are designed, I could never actually get an implant to run. Now, yes, you could drop a web shell, but once again, you wipe the box and reinstall and restore it from a backup, you're done. So put some thought into the devices you buy. Like, try to make sure, you know, hey, if you're going to go buy an F5, like, hey, did you see that guy's talk? Like, should I really spend the money with you guys? They would love it if you did that. Yeah, so it's like I said, it's the Wild West. I hope that you can all stay safe. I hope that you've enjoyed this talk. I have like less than a minute for questions. I want to be respectful, so maybe just find me afterwards if you're interested in things. And thank you again, Ekoparty, for having me, and thank you for being here.